Okay guys, we got our voltmeter hooked up and we got our amp meter hooked up so we could check the power right away. I'm gonna hook up this 21 LEDs here. All I gotta do is attach one more wire. Let's see here. Come on. Well, I saw flash. They are lit up. They are lit up. And we got 2.45, almost 2.5 volts. And over here we got about 35 microamps. Not sounding that good. Alright, let me go and do the math on that. And I like that these LEDs are lit up. I wonder if I can get the string of 100 LEDs lit yet. I don't know. But yeah, the LEDs look pretty good right now. So yeah, let me go do the math and let's see what our power is out of this one. Alright guys, this is I put the original circuit back on and I got the 21 LEDs lit, and with this one I got 2.5 volts, almost the same exact thing I had with the other circuit. And now with the other circuit I was only getting 35 microamps. With this one I get about 60, 55, 60. So I don't even have to do the math. I mean, that's telling me right away that we're getting more power from this circuit than we are from the other circuit. Let me think. I'm gonna go ahead and try the string of many LEDs together, and I doubt if it'll light them then, since I'm not getting more power. Looks like it's a freezing temperature outside today. It's like 33 degrees or something. So I'm not going to want to be working up on my roof that much more outside. But I'm thinking I still need a better collector to get more power or something. Let's see, I'm also going to try to run or power a little tiny motor. But yeah, let me see if there's any luck with the string of LEDs. So far I think that other circuit I made, the Cockcroft Walton, is not beneficial to us in this situation. So okay, on to the next thing. Must think. Okay, here's this isn't even the full 100 LEDs. Probably about half of them or something here. Okay, we got this other circuit back because we had more voltage with this one. And that's the thing you need. I've already hooked this up to my power supply, and I know I need at least about 7 volts to get this to light up here. I mean, right now we're 15 volts, and we'll be able to see some current on there as soon as I connect this. Let's see if we could even see this thing. There it is. See the flash? Little tiny dot. Flick, flicker, flicker. Very, very weak. Alright, I'm going to leave that plugged in. And we're down to 4.73 volts. Remember I said I need about 7. And over here we got about 28, 27, 28 microamps. So yeah, I still have to raise the voltage and not lose the current. And I think I mentioned at the last end of my previous video, I have an idea, somebody gave me an idea of a really good coil setup. I'll have to try that out, and I don't know why or how it would work. Seems like it would defy the laws of physics, but we'll have to build that, I think, next. Some bucking coils and another coil wrapped around the bucking coils. So that'll be my next project, to make those coils. But for now, guys, no luck yet. Nothing. I gotta increase our power a little bit. Maybe I could still. I keep thinking of using uraninite ore sample. It gives off a lot of radiation. Maybe I could make some kind of a container or something to, with that sample in there and my antenna wire going through it, so I could have that radiation hit the antenna wire. It's just another idea of something I want to try in the future here. But okay guys, that's it for today. Yeah, like I said, I'll have to try that coil design next. We gotta get 100 of these lit, and I don't want to do it by tuning in very specifically to a radio station or anything like that. Okay, it's the point of gathering the energy that's all around us, even if the radio stations go out. Hopefully. So, okay, till next time. Thanks for watching. Please subscribe, share, give it a thumbs up. You know, give it that big icon with the thumbs up thing. Alright guys, I'll see you next time. Okay, here's the coil we're gonna try. I got that made now. Good friend of mine, Richard, sent this to me. I'm not sure if I saw this years ago or not, but he really brought it to my attention at a good time. I'll leave a link to this video, but it's called Free Energy January 2015, How Partnered Output Coils Work. And here's the coil. So there's 9 windings. 9 windings. They're opposing each other. So they're bucking coils. And that's said with a B, not an F. They are bucking coils. Although I might get frustrated at times and call them the other thing. But okay. Anyhow, so we're gonna hook this up and see what happens. Supposedly in the video they talk about this coil will increase the voltage but not lower the current, which seems interesting. So we will see, won't we? The hard thing about it is how we're gonna hook it up. So you see I got some notes there. Large green primary goes to antenna and ground, and the smaller yellow secondary will connect to 2 circuits. We'll try that way. Richard suggested connecting it that way. I think it makes the most sense so far. We could always do experiments and try hooking up different ways, but okay, let's see what happens, and let me see if I can get that hooked up here. Okay, so there's our coil. Before I hook it up, just real quick, I just wanted to there's T.O.'s cell over there, and here's the free energy from air. And it's just so cool. I just had to comment on this real quick. T.O., if you could, leave us some comments on what ingredients and everything. Give us some details about that. I'll kind of tag that comment to stay at the top of the list. YouTube's just added that feature recently. Just so cool to have, you know, energy lighting up these lights. And these things work 24/7. Doesn't matter if it's sunny out or nighttime, or if the wind is blowing, or if that current is flowing. You know, it's free. You don't have to pay for it. 24/7. And let's see, T.O., you had that cell for what, a couple months, or how long? How many months has that been going now? You got to give me an approximate date. I'll mark it on the bottle there. Maybe I'll have to make a whole video of that. But alright, let's get back to connecting this up and see how this coil here works out. Okay, enough playing around. Let's get that new coil hooked up and see what we got here. I just want to show you this real quick. This is the antenna and the ground just hooked up by themselves. I'm getting 0.172 volts AC. Now I'm going to tell you, this video clip you're watching right now is filmed 1 week later than the previous video clip you just saw. A week has already passed since I've made my coil and haven't tested it yet. A lot of holidays going on, I'm sure you understand. But anyhow, I'm telling you it's a week later because temperatures have really dropped. I got snow on my lab here. 0 degrees. I'm getting about 0.175 volts, but I know in the past I've had 0.2 and 0.3 volts. So I don't know if the cold temperatures are affecting how much radiation is in the air or something. But anyhow, I just wanted to show you what we're getting right now. Okay, so now we're going to hook our new coil up. And let's do it first with AC. Let's put that down. Let's see. This is our primary. And okay. Like I said, I don't know how to hook this thing up yet. It's AC, it shouldn't matter which side I put these probes on. 0.00543, it's going down. Wow. Alright, let's see. Can you see this in the viewfinder? I'm not blocking everything, am I? Yeah, you could see the meter there. Wow. 0.001 volt. This is do I have things backwards here or what? Am I supposed to be transforming it's supposed to be stepping up here. I'm pretty sure I got that right. We could real quick change this around, but I know we had it right. Because this should be, whoops, this should be transforming the energy down, stepping down this way. 005, 04, 03. So this is a alright, it's like the coil's not working or something. I'm wondering if need a lot more windings on that coil. Alright, give me 2 seconds. Let me hook up our circuit here and then put this on the output of our circuit, so we'll be working it with DC. Give me 1 second. Okay, I got this circuit here back on now. Right now, I don't know if you can see it, I'm getting 13, 14, jumps around a little bit. Hope you could see that okay. It jumped up to about 19 volts a little while ago. Fluctuates a little bit. Seemed like last week I was around 16, 17, so I am a little lower. Okay, let's go ahead and connect our coil on the output of this down here. Disconnect the meter. Primary. And took our meter. Now this is all DC now. Oh, 0. What the heck am I doing wrong? Zero volts. I'm DC. What the? I think we're gonna have to multiply the windings in that coil or something. 0. I gotta be hooking it up wrong. Let me try one more thing. Hang on, guys.